Hi guys, welcome back to 13.2, Angles and Parallel Lines. A line that intersects two or more lines at different points is called a transversal line. If you're looking at this figure right here, we have line 1 and line 2, and then we have one line that intersects both of them at different points, here and here. This vertical line is our transversal because it's the one line intersecting two lines simultaneously. When a transversal intersects two lines, several pairs of angles are formed. So just by having this one line cut through it, all of a sudden I ended up with angle 1, angle 2, angle 3, and 4. And then I have 4 as well in my second line, 5, 6, 7, 8. So one line created 8 angles. So messy. Two angles that occupy corresponding positions are called corresponding angles. Remember, corresponding position just means they lie in the relatively similar position. So we have our top wedge and our top wedge, side top wedge, side top wedge, bottom side wedge, bottom side wedge, bottom side wedge, bottom side wedge. They match up. They're symmetrical. If you were to put them on top of each other, you would still have top corner, bottom corner, bottom corner. That's what that means. Two angles that lie between two lines on opposite sides of the transversals are called alternative interior angles. So one more time. Two angles that lie between the two lines on opposite sides of the transversal are called alternative interior angles. Angles that lie outside the two lines on opposite sides of the transversal are called alternate exterior angles. So let's look over here to see what they're talking about. Alternate interior angles. They say 3 and 6 are alternate interior angles. That means they lie opposite to each other. So we have top, or I guess inside outer corner, outside outer corner. They are lying opposite to each other, but they're still inside of the house, if you will. They're resting inside the two lines, but they're in the opposite positions. That means 4 and 5 are also alternate interior angles. They're still resting inside, so they're interior, and then they're opposite angles. They go across the line. And now same thing with alternate exterior angles. We're talking about the ones that are on the outside of our parameters, ignoring the inside, just looking at the outside. So we have 1 and 8 because they're in the opposite position. And then we have 2 and 7, which are in the opposite position. Example 1, identifying angles. The skyscrapers in the diagram of John Hancock Center in Chicago, line T is transversal. Tell whether the angles are corresponding, alternate interior, or alternate exterior. So I'm going to draw it out, drawing out this picture right here. I have line M, and then I have line N that are just parallel to each other. And then I have this transversal line. So it's just two beautiful, easy lines, no angles. Then all of a sudden, this line comes, and it becomes our transverse. And it's going to mess it up by giving us all of these internal and external angles. We have angle 1, angle 2, angle 3, and angle 4 all on line M. Then we have angle 5, angle 6, angle 7, and angle 8 all on line N. And our job now is to say what are our corresponding angles, what are our interior angles, or interior alternate angles, and then our exterior alternate angles. So remember that corresponding angles are two angles that occupy corresponding positions. That means they just rest in similar positions in our diagram. So question A says, where can I write it? A says, what are angle 1 and angle 8. Again, when they just say A, they're asking what are those two angles. All right, so we have 1 and we have 8. 1 and 8, step 1 is to notice they're both on the outside of our line. We have our interior angles that are sandwiched between M and N, And then we have our angles that are on the outside of M and N. We notice that 1 and 8 are on the outside. So that tells us right away we have some exterior angles. They're on the exterior of the transverse line. So for A, so far, we have exterior. And if we notice, they're in opposite positions of each other. So we have exterior alternate angles, or alternate exterior angles, either way. Alternate exterior angles. For B, they ask us about angle 2 and angle 3. Angle 2, or not 3, and angle 6. Angle 2 and angle 6. So let's identify them. They're right here, angle 2 and angle 6. First thing to notice, they're in corresponding positions. They're both on the right-hand side top corner of our original lines, M and N. Because they're in the identical position, we know they're corresponding angles. Identical position means corresponding. That if I were to take this one line, cut it in half, and just put it right on top of each other, they would match up perfectly. If they match up perfectly, corresponding angles. So B, we have corresponding angles. There we go. And now lastly, we have C, which asks about angle 4 and angle 5. We have to identify where they are. We have angle 4 and we have angle 5. Right away, you should notice that they're both sitting on the inside of our plane. Because they're on the inside, we know we have some interior angles. And we notice that they're in opposite position of each other, top corner to bottom corner. Because they're on the inside, interior. Because they're opposite, that means they're alternate. So alternate interior angles. All right. Moving on. Transversal and parallel lines. When a transversal intersects two parallel lines, certain pairs of angles are formed that have equal measurements. So they're saying you have two parallel lines, boop, boop, and you can't see that because it's half off the camera. My bad. There we go. And then your second parallel line, and then you have this transverse that kind of cuts right through it. All right. Looking at the diagram, we have T, angle 1, 2, 3, and 4, angle 5, 6, 7, 8. Our corresponding angles, they say, are 1 and 5, 2 and 6, 3 and 7, and then 4 and 8. Again, if we were just to take this top picture, kind of cutting it right there, put them on top of each other, they would be the pieces that match up perfectly. And then we also have our alternate interior angles, which are going to be 3 and 6. They're on the opposite. 4 and 5 are on the opposite. 1 and 8, which are on the opposite. Well, those are our exterior angles now. And 7 and 2 on the opposite. So we have a predictable pattern. So now they're saying, for example 2, in the diagram of transverse T intersects parallel lines M and N. So we'll make this one M and this one N. If angle 1 is 75 degrees, find the measures of the other angles. All right, again, this is when you get to like these fun Sudokus, where it becomes actually quite easy once you know one measurement. Because we're going to play on our knowledge from yesterday that vertical angles, meaning angles that are opposite from the split, are equal. And then we're also going to rely on our knowledge that a straight line assumes it has to be 180 degrees. So because we know our vertical angles are equal from yesterday's chapter, if 1 is 75, that means 4 has to be 75 because they're vertical angles. 75. And again, we're going to ignore our bottom half for right now because it doesn't necessarily help us right now. So we're just going to put that card over it so we don't think too much about what we don't have to worry about yet. If we know that a straight line has to sum to 180, and we know that top angle is 75, 75 plus whatever angle 2 is has to equal 180. So 75 plus our unknown value has to equal 180. Subtract 75 from both sides. That cancels out. X is equal to 105. So that means this angle has to be, what? Okay. My line is going the wrong way compared to this picture. So our angles will not make sense, but that's because I was supposed to draw my transverse line that way. But we're just going to go with it for right now. So we know that this internal angle is 105 because that's what angle 2 has to equal in order for us to have a straight line. And again, it should actually be switched. This one should be 105, this should be 75. But looking at our book right here, I accidentally drew my line going this way where their line is going this way. So just bear with me. Our angles are going to be like off, but they're only off in the opposite way because I drew my line the opposite way. Okay. Going again with our vertical angles, if we know angles that lie opposite to each other are equal, that means 105 is also going to be angle 3. So now I filled in my entire top corner, and now I have to fill in this bottom piece. Easy enough, because they told us here that corresponding angles have equal measurements. They're the exact same. Alternate exterior angles also measure the exact same. Alternate interior angles measure the exact same. So we need to start looking to see what our alternate interior and exterior angles are because they measure the same. So what is 5's alternative interior angle? Well, it's the one opposite to it on the inside. So 5's alternate interior angle is right here, and if it's 75 there, that means it's 75 here. 6's alternative interior angle was originally 3, which is right here. If its alternative interior angle measures 105, that means 6 is 105. And so now we've done all of our interior angles. Now we just have to do our exterior angles. So remember, our exterior angles are the ones opposite to each other. Boom and boom, boom and boom. So if 7's alternative exterior angle measures 105, or if all alternative angles are equal, that means 7 has to be 105. If 8's alternative angle measures 75, that means 8 has to be 75. And we figured it out all based off of one